The universe we live in is nearly 14 billion years old. It has created the raw materials for everything we see around us. The stars, the planets, trees, cities, automobiles, even us. Our world is complete, but the universe is still evolving. Scientists have come up with many theories on how it will end.
We know our universe began in a Big Bang. What we don't know yet is what the future of our universe is going to be. Our universe may end with a bang or a whimper or something even more exotic.
One theory suggests that our universe will run out of steam and stop expanding. Every star, galaxy, and planet, every atom will start to collapse, ending in a single super-dense pinpoint known as the Big Crunch. To find out if the universe really is going to crash back in on itself, scientists first need to discover if it's still expanding or if it's slowing down. Astrophysicist Saul Perlmutter studies the death of the universe by finding beacons in space, exploding stars called Type 1a supernovas.
If you have enough of these exploding stars, these supernovae, that you've measured their brightness, so the ones that look fainter and fainter and fainter must be further and further and further away. And so you have some supernovae that are a little bit brighter, they're more nearby, some that are a little bit fainter, so they're a little bit further, and some that are very faint, so they're very far away.
Type 1a supernovas are similar to the supernovas that created the heavy elements. They differ in one important fashion. They always explode with the same exact brightness. This is because they are created in the same way. Two stars circle each other, held together by their gravitational attraction. One is shriveled and super dense, glowing with white heat, a white dwarf. The other star has bloated to an enormous size. It's a red giant that is burning the last of its fuel. As the two stars orbit each other, the white dwarf sucks gas from its companion and begins to grow year after year. When it is precisely 1.44 times the mass of our Sun, the white dwarf crumples, collapses, then explodes, releasing a blinding burst of energy. Every Type 1a supernova explodes at the same tipping point, and so are equally bright and visible across the vast distances of the universe. Perlmutter needs to find hundreds of Type 1a supernovas and then measure how fast they are moving away from us. He links up the most powerful telescope on Earth with the most powerful in space. Using advanced cameras on the Hubble Space Telescope and a giant telescope officially known as the Very Large Telescope, or VLT for short, he hunts for supernovas. Once Hubble has detected a particular light source, colleague Chris Lidman at the VLT analyzes the object to see what it's made of and make sure it's a Type 1a supernova.
This object is a distant galaxy, and next to it is what we believe is a distant supernova. The next crucial step is to understand what type of supernova this is.
The VLT breaks down the light from the object into its spectrum.
You want to be able to break up its light into a spectrum and look for the very characteristic fingerprint that you would see if it really were a Type 1a supernova.
The light emitted from this particular supernova reveals that it's a Type 1a. Lidman can now calculate how far away this supernova is.
The supernova exploded about 7 billion years ago.
By comparing the positions and dates of all these supernovas stretched over space and time, Perlmutter can calculate whether the universe is slowing down. His results are a shock. The expansion of the universe isn't slowing down at all.
When we began the project, of course, the goal was to find out how much the universe was slowing down. Now, when we actually started looking at the data, it looked like the universe wasn't slowing enough to come to a halt. And in fact, it wasn't slowing very much at all. And in fact, when we finished the analysis, it looked like it wasn't slowing, period. It was actually speeding up in its expansion.
Perlmutter's astounding discovery means that the universe will not grind to a halt then crunch back down into a pinhead of superdense matter. Quite the opposite. It will continue to expand faster and faster. Our universe is literally flying apart.
The expansion of the universe will accelerate at ever faster and faster rates until literally everything will get ripped apart. Not just galaxies, but eventually matter, the Earth, all the objects, stars, the Earth, planets, people, atoms, in a finite time would get ripped apart.
Long after our sun has burned out, 100 billion years in the future, galaxies will pull apart. The universe will be made up of isolated stars, which are running out of energy. Some will become white or brown dwarfs. Others will collapse into neutron stars or black holes. Then, thousands of trillions of years after the Big Bang, even the black holes will evaporate, and all matter will decay to its basic ingredients. Atoms will fall apart, and even protons, the building blocks of atoms, will decay.
The most likely future is perhaps the most dismal one, where the universe becomes cold and dark and empty.
As the universe continues to expand and the galaxies speed apart from each other, space will become empty and dead.
Our own cluster of galaxies will be moving away from us faster than the speed of light and will disappear from the night skies.
Eventually, everything will just sort of wind down, and that's the end of things.
Finally, the universe will die, and all that will be left is a cold, dark, and lifeless space.